All right, so today's lesson is on translating word problems. Our objective: students will utilize the 3-read strategy to identify important information in word problems, and then translate the verbal expression into a mathematical expression and solve. So we'll jump right into it. Example number 1. Raj went to a competition at the local arcade one day. The purpose of the competition was to see the most amount of tickets a person could win in 1 hour. The cost of admission was $6, and each game cost 75 cents. After the hour was up, Raj had spent $13.50 total. Write an equation to represent Raj's total amount spent, then solve the equation to see how many games he played. So we're going to take this word problem, we're going to apply the 3-read strategy to it, and then we are going to set it up and we're going to solve it. Okay, and this will not be our only day on word problems. We have a few more days that we're going to keep looking at them. So just take it slow. I know word problems are a struggle. Okay, so your first read when you read a word problem is just to figure out what the situation is about. I'm going to read this again, and you guys are going to write me a sentence or two, whatever you've got, about what the situation's about. Raj went to a competition at the local arcade one day. The purpose of the competition was to see the most amount of tickets a person could win in 1 hour. The cost of admission was $6, and each game cost 75 cents. After the hour was up, Raj had spent $13.50 total. Write an equation to represent Raj's total amount spent, then solve the equation to see how many games he played. Remember, for this step, you're just telling me what is the question about. All right, let's take a look at what we got. So I think dollar sign and then 450, but that'd be like time. Not sure what's going on there. The situation is about who can win the most tickets in an hour. Yep, absolutely, that's perfect. The solution is about the cost of the admission is being multiplied. The situation is about the competition to see the amount of tickets someone could win in an hour. Excellent. Okay, so 60.75 games Raj played. All right, I want to talk about that for a second. Think about a game. Well, I suppose you can play half a game, but since there was no winner, I'm not sure if that counts as the game getting wholly played. This is good too. The situation is about that he went to a local arcade and spent $13.50. And they were going somewhere, but they ran out of time. I don't know. I appreciate that. But yeah, remember for the first read, you're just looking through the word problem to figure out what is it about. You're not trying to do the math yet. Slow down and read these word problems. Sometimes that can really help to be clear on a situation. All right, our second read. Highlight or circle information. So I'm going to read it again. Raj went to a competition at the local arcade one day. The purpose of the competition was to see the most amount of tickets a person could win in 1 hour. The cost of admission was $6, and each game cost 75 cents. After the hour was up, Raj had spent $13.50 total. Write an equation to represent Raj's total amount spent, then solve the equation to see how many games he played. So let's take a look at what we got. All right, well, this is lovely, but not very informational. All right, so this part is good for the context. The most amount of tickets a person could win in 1 hour. Well, that's true for context. It's not really important mathematical information. Cost of admission is $6. That's perfect. Yeah, Each game costs 75 cents and $13.50 total. Those are all really good things, so good job on those. Yep. Those are good things. Didn't need the first part. This is good. Write an equation. Total amount spent. Yeah, it looks like you're finding. This first sentence is completely irrelevant. $6. So it's good to understand the context of a math problem, mostly because if you understand the context of the problem, it'll help you keep from getting ridiculous answers. Helps you try to kind of remember like what types of numbers you should look at. Pick it. Okay. All right, so we're on the right track. And the third read is about what questions do you have? So I'll read this again. And you guys should come up with some sort of question. And if you really don't have one, you don't have one. Raj went to a competition at the local arcade one day. The purpose of the competition was to see the most amount of tickets a person could win in 1 hour. The cost of admission was $6, and each game cost 75 cents. After the hour was up, Raj had spent $13.50 total. Write an equation to represent Raj's total amount spent, then solve the equation to see how many games he played. I'll give you guys a minute. All right, let's take a look. How much to get all the tickets? Okay, no questions. I don't have any questions. 70 hours he stayed just to play games. It says he played games for 1 hour. 70 hours of video game playing would be intense. Do we have to do any multiplication or division? That's okay. That's a pretty good question, I guess. All right, so now we're going to learn how to break this down and turn it into an algebraic equation. So here we go. All right, so as you can see, I went through and I did some little things. I crossed out the first whole part because we don't need that mathematically. That gives us an idea of what's going on in the problem, and they can help us keep the numbers realistic, but not important for the math. There's no math in there. So cost of admission was $6. Each game cost 75 cents. Raj had spent $13.50 total. How many games he played? Okay, those were the most important things to focus on for this problem. All right, so I pulled it out. Important information. Cost of admission is $6. Each game costs 75 cents. Raj spent $13.50 total. The question asked me to find out how many games Raj played. So if I'm going to try to process through this information, here's how, as your math teacher, I think about this problem. All right. The number I do not know is the number of games played. That's literally what the question is asking you. Unknown numbers are represented by variables. Remember, that's your cardboard cutout, that's your stand-in. When I think about paying admission to get in somewhere, I only have to pay one time to get in. So let's say I was going to the movies. I'd only pay for one ticket for myself. But if I wanted popcorn, every time I go to get more popcorn, I probably have to pay. I know sometimes you get a free refill, but at some point they make you buy new popcorn. Like popcorn's not unlimited. When I think about paying to play a game, I have to keep paying that cost over and over again when I play a new game. So when you go to an arcade, every time you go to play, you got to put the quarter in, the token in, the number of quarters in. I know most of those are not a quarter anymore. They were when I was a kid, but not so much now. But yeah, you have to keep putting tokens in. You want to play the game, you got to pay again. But once you're in, you're in. You only pay admission once. And the clue word we can see with that is each. We talked about the word each last week. Each usually means we're going to multiply. So in order to set this equation up, I'm going to look at these numbers and figure out where the pieces go now. My variable represents the number of games. The cost for games is 75 cents. You also have the word each. You're looking for each, every, per, words like that. Therefore, I can write 0.75x to represent the cost of games. So we know that that one's going to happen over and over again because we see the word each. It also makes sense to us when we think about it. And if you think about the fact that X stands for games and the cost of games is 75 cents, hopefully you can see a connection between those two things. They both are talking about the games. Another cost Raj had was admission. I need to add that onto the total cost. Now I have an expression about the cost. So I have 75 cents times the games, and then I have to add on that extra $6 that Raj spent just to get in, because that's part of the money he spent while he was there. And you know that the total amount of money he spent was $13.50. So 0.75x plus 6 equals $13.50. $13.50 is the amount of money he spent. The amount of money he spent is also 0.75x plus 6. They're both the same thing. So hopefully that helps it make sense. All right, we have our equation, so let's solve for x. Let's do just a touch of math this morning. So we have our equation, so let's solve for x. I'm not sure where we're going there. This is the right answer, but I don't see any work here. It's very pretty, but this one's perfect. Subtract 6 from both sides. 0.75x equals 7.5. You divide through, you get x equals 10. That's perfect. Right answer, but no works being shown. Oh, okay. Well, that's helpful. That's good. All right. We'll wrap this problem up. Maybe we'll do the next problem next class because I had 2 problems I wanted to go through today. So we know that x equals 10, but what does that mean? We said that x stands for the number of games. So the answer to the original question is Raj played 10 games at the arcade. When you're doing these types of word problems, especially on the state test, they expect you to be able to write at least one sentence about the answer you found. So x equals 10, that is the answer to the math. But if you remember, our problem wasn't about solving that equation. Our problem was about a guy who went to an arcade, played in a competition, and the thing we were trying to figure out was how many games he played. So hopefully it makes sense. A good answer to this would be Raj played 10 games at the arcade. Like that answers that question. All right, does anyone have any questions before I start kind of wrapping class up, I guess, today? Okie dokie. Our summary. Use the 3-read strategy to help you understand the problem that you are trying to solve. Unknown numbers, usually the question at the end of the word problem, are the thing you use a variable for. When setting up your equation, make sure you pay attention to which number should go with the variable and which number is a one-time thing.